we're kind of running out of time, so we'll just take the last couple of questions.
I guess we're running out of time. How many minutes do we have? 5 minutes, okay.
My question is quite short. You mentioned HAVOC being based on open source technology. I was wondering, is it itself released as open source?
Can you repeat, please?
You mentioned HAVOC being based on open source technology, and I was wondering if it itself is released as open source. Or
yes, yes.
closed.
Boogie is open source. So you can actually take Boogie and apply it for yourself. However, the part that does the translation from C to Boogie is not open source. So it's tightly coupled to the Microsoft compiler, which is why it's not open source.
Yeah.
So you would actually say you want to reproduce this work for GCC, you would have to write the compiler plugin that does the C to Boogie translation, and after you can use Boogie to do all the same analysis.
Okay, thanks.
In a few words, can you give some hints what the last chapter, near zero condition, is?
I could give an example, but it would be
just
a little
time.
Basically, sometimes you let's see this slide. Sometimes you read the value from untrusted source. So say you have this function get value length that reads status arrow integer count. So you don't know the value of that, but when you do the malloc, you do this value plus 2. So the size holding variable is 0, but the size of the allocation is not 0. So if you check the precondition of the malloc function here, it's not going to trigger anything because the size is not 0. So require size different than 0 is true, right? However, you can have, say, an integer underflow on this variable. So I would have to explain it, and it's kind of a big example, so I don't have time to do that. But basically, in short, you can have an integer overflow or whatever integer condition, and it makes that the size holding variable is desynchronized with the actual allocated size. So this can be dangerous, and you cannot check it, you cannot find those with the simple precondition I described because it requires size different than 0 is always true. Am I answering your question? The slides are available, so you feel free to look it up later and send me an email, or like we can discuss it afterwards. I'll be pleased to answer your questions more in depth.
Can I ask a question? So I think all your examples contain just the unsigned integers. What about casting, propagations, and all the rules associated with comparison of signed, unsigned integers, short, long, and also floating point numbers? How do you model it in SMT? And
thank you. It's a very good question. So this tool supports bit vectors. So the constraint solver we based on, Z3, has pretty good theory for bit vectors. So you can define a theory that talks about bit vectors, and so you would be able to find problems related to typecast and everything. So we've done that. However, in some cases, it's very, very difficult to do all automatically because you can have arithmetic on 31-bit size bit fields. And so if you do a cast from 32 bits to 31 bits, then you would actually have to track the fact that the bit field is just 1 bit less. And so you can have an integer condition on the bit field. So tracking that, like on the whole kernel, is sometimes hard. So it happens to us that we have some condition that says, oh, well, first of all, we run the analysis assuming that everything is 32 bits. And then we say, oh, okay, now we just put the option in the theorem prover to say that, okay, now we differentiate the 16-bit and the 32 bits, and then we just see the difference between the warnings. So that allows us to focus on those examples, on those warnings where just adding this new axiom give us a couple of additional warnings. So yes, the tool is able to differentiate those cases. However, it's more time consuming to do it because bit vector theory takes more time.
I'm sorry, so apparently we are running out of time for the next talk. So I think we should thank Julien for patiently answering all the questions, and if there are any more, please take it away from the hall. Yeah.
Thank you. Thank you.